This time around, I want to look at geometric progression. Geometric progression is one of the topics which is taught to grade 11s, and this is syllabus D. So geometric progression is subtopic 2 under sequences and series, and this marks to be topic number 2 in grade 11. The first one is approximation, then followed by sequences and series. In this video, I am going to cover geometric progression. Since geometric progression is too wide, I'm going to do it in parts. Maybe it is going to be part 1, part 2, and part 3. Then that way, the subtopic is going to be concluded. So without wasting time, I'm saying geometric progression. And what is this geometric progression all about? Geometric. Geometric progression. What is this geometric progression all about? So I'm sure you are able to see the title there. This is geometric progression, or GP. So the other term you can use for a progression is what? A sequence. In some books you may find that this is going to be written as a geometric sequence. So in a geometric progression, the numbers are going to be following each other, agreeing to a certain pattern. So these numbers in a sequence are said to be terms. Like for instance, let me start with the first number, and this first number is going to be a 2. Suppose we have a 2 as the first number. This is a 2, followed by, let's multiply 2 by 4, we are going to get 8. 8 by 4, we are going to get 32, etc., etc. The numbers will keep on following. So in my example, allow me to look at the first three numbers of the geometric progression that are consecutive or that follow each other. So the first one is 2, and you have multiplied 2 by 4 to get 8, 8 by 4 to get 32. Then in 32 by 4, you are going to get another number that can follow, like that. So now, these numbers which you have seen are said to be what? The terms. These numbers are said to be what? Terms. So these are terms. So in shorthand, this is term number 1, term number 2, and term number 3. So what I'm trying to say, these numbers are called what? Terms. Each and every entry is called a term. Shorthand, term number 1. So now there is also what we call as what? Nth. This nth is all about the position number of the term. So if the term is in position 3, n is going to be 3. So this nth is the position number of a term. So in my lesson, this is n is equals to 1, which means what is the first term? N is equals to 2. And this is n is equals to what? 3. So this will be regarded as what? A language. T1, it means term number 1. T2, term number 2. Term number 3. But this nth, it means the position number of a term. And we call this as what? The nth position. And you find that in the examination questions, they are going to make a pronouncement to say, find the 20th term. Because of where 20 is mentioned, it means they want you to raise or to find the number which is in position number 20. I'm sure that is understood. These are the terms. So now, the first thing that you need to know or to identify is that you need to know that the number always in the first position is called the first term. And this first term can be represented by A. So like in this respect, the first term is 2. So this is 2. Another thing that you are going to know is what? A common ratio. What is this common ratio all about? And it can be presented by small letter r. So to find the common ratio means if you have a term, this term is going to be, there is n there, again another term, then there you say n take away what? 1. This is the general formula. Suppose the term is 2. So this is going to be term 1 because it is 2 minus 1. Look at this n. then n minus 1. So if this is 2, 2 minus 1 is 1. Same applies, common ratio can be found if the term is the third term, then down there it is 2. 3 minus 1 it is 2, like that. So to arrive at the common ratio, suppose you want to find the common ratio. First term is 8, second is 32, so this is 32 over 8. And the common ratio is equal to 32 divided by 8 to get a 4. I'm sure that is understood. Same applies there. The third term, 1, 2, 3. This is going to be 32 divided by what I've treated there is first term and second term. So now if it is the second term and the first term, the second term is what? 8 divided by first term, which is 2. Still you are going to maintain that this is going to be what? To be a 4. So that is how to find the common ratio of a GP. So together the first term, which is equal to what? 2, and the common ratio that is equal to 4. Questions that are going to come after this, we are going to rely on the first term and the common ratio. So we are going to be using first term and common ratio as a tool to tackle that. And actually the second thing after this, it is nth term. What is this nth term of? Nth term of a GP, meaning that geometric progression. This nth term is given by Tn equals a then common ratio n minus 1. So this is the formula for the nth term. So if you want to find the number in any position, that is the formula that you are going to use. But this one can be derived. Each and every sequence can have its own formula for the nth term. Like in this sequence that we are using 2, 8, 32, we can find the formula for the nth term. And what can be this formula for the nth term? What can be this formula for the nth term? So this new formula for the nth term, you write Tn equals the first term, which is 2, common ratio, that is 4, to the power n minus 1. So that is the formula for the nth term, but it can be simplified. This is nth term formula. It is 2 divided by 4. You divide this by 4, then that way 4 remains the common ratio, n minus 1. Then minus 1 should go. This is just n. So looking at that, this is nth term formula is equal to, when you divide it is 0.5. And then 4 to the power n. That is the nth term what? The nth term formula. So this one is driven from that. So this can only suit the sequence, which is 2, 8, 4, and this is a GP. I'm sure for part 1, this is where I've ended.